Okay, in this video, if I don't make any mistakes, I'm learning how to, I'll be showing you how to do numerical methods as well as do some graph sketching. Now here, on question A, we've been asked to find the coordinate A, coordinate B, and also the value of K there. And you're told that this graph, g of x, is this thing here. So let's see how we'd go about sketching this one. So e to the power of x is a graph which looks like that, and it goes through at 1. Now e to the power of 2x, so we're replacing the x with a 2x, so that's kind of inside the bracket, so e to the x, and then inside the brackets we're going to replace it with 2x. And because we're timesing it by 2, it means it's going to squish everything twice as close. So it's going to look like that there. Now, if we're going to times that by 4, what's going to happen is we're going to stretch it going up and going down. So therefore, this 1 is going to go through at 4, and it's going to make it a lot steeper. And it's going to go down. But still never touch the x-axis. And then what we're going to do is we're going to take away 25. So if we take away 25, that means taking our curve here and just moving it down by 25. So if it goes through at 4 at the moment, it's now going to go through at minus 21. It's going to do something like that. And whereas the asymptote beforehand was the x-axis, if we go down 4 from that, that's going to be at minus 25. That's the asymptote down there. Now the next thing they do is they stick it all in the modulus brackets, which means that we're going to bounce it up from this point here. So it's going to go up like that. So instead of going through at minus 21, it's going to go through at 21. And instead of having minus 25 as the asymptote, it's going to have the asymptote there of 25. So now, the y-coordinate point A. So the y-coordinate is 21. The x-coordinate point B. So what we've got to do is we've got to find out what the x-coordinate is. Now we know the x-coordinate is when y is 0. So we're going to let y equal 0. So 0 equals modulus of 4e to 2x minus 25. Now, we can actually get rid of the modulus brackets because the modulus brackets are only for this bit here. Now, where the original curve hits the point B there, that's not actually modulus. It's modulus and not modulus at the same time because this bit here is just the original curve, so the modulus doesn't affect it at all. And it's just at that very second, or the second after it bounces back up, that the modulus comes into effect. So we can actually just solve 0 equals 4e to the 2x minus 25. Next thing we're going to do to solve that is we're going to add 25 divided by 4. So e to 2x equals 25 over 4. We're then going to take logs of both sides. So you're going to have, if you take logs of this side, you're just going to be left with 2x. And that's going to be log of 25 over 4. Then you're going to divide by 2, so x equals a half log 25 over 4. And it says write it given each answer in its simplest form. That kind of looks simple, but the power of a half, so that half, we can actually use that as log laws and bring it up to here. We say that x equals log of 25 over 4 all to the power of a half. Now the power of a half just means square root. So we're going to do the square root at the top, square root of the bottom. So x equals log of 5 over 4. And there you go. And then the value of the constant k, that's the asymptote that we were talking about over here, which is 25. So job done. 5 marks for that. Now the equation gx equals 2x plus 43 has positive root at x equals a. So let's actually work out what that means. Let's get rid of all this jazz here. So we're looking at the equation of a line 2x plus 43. So we know this is 21 there, we know this is 25. So 43 is going to be up here somewhere. Y equals 2x. A straight line that does that. It's going to have two solutions. That's where g of x, which is our original curve, is this line. You're going to have two solutions, one here, and then one over here. Now the way we're going to find out those two solutions is we're going to set the equations equal to each other and solve for this bit here and this bit here. Now there's a difference here. For this one here, the curve hasn't been reflected, so we don't need to worry about the modular signs. We can just solve 4e to the 2x minus 25 equals 2x plus 43. This one here, we need to solve the modulus. So the way we solve a modulus is we just times everything inside the modulus brackets by minus 1. So that would be minus 4e to the 2x plus 25 equals 2x plus 43. But because we aren't looking for this one, we're not looking for the one that's been bounced up from the modulus. We're looking at the one where the modulus hasn't had any effect, this one over there. So therefore, we don't need to worry about that. Now, it says show that alpha is a solution to this. So the way we do that is we rearrange to get x equals. If we have a look at what we need to get, because this looks a little bit messy, and there's a couple of x's that we need to look at. But if we've got a log in there, it means that we've had to get rid of the exponential. So therefore, I think we need to make this x by itself. So first of all, let's add 25 to both sides and divide by 4. So we've got e to the 2x equals 2x plus 68, and then all divided by 4, which is e to the 2x equals 2x over 4, so it's going to be a half x. 68 divided by 4 nicely gives us 17. They're going to take logs of both sides. So that's going to be e to the 2x equals log of a half x plus 17. Oh, what am I doing? I've taken logs, I've got to get rid of that e. There you go, so 2x equals log to the half of x plus 17. Then you're going to divide by 2, so x equals a half of log half x plus 17. So there you go, that's how you do that one. And now it says, oh, so we've got that as an iteration formula. Taking x0 as 1.4, find the values of x1 and x2. So what we do is we just simply substitute in x0 into our formula there to get x1. So x0 is 1.4. x1 will equal. So do 1.4 into there into your calculator and see what you get. And doing that on the calculator, you should get 1.4368 if you round to 4 decimal places as they've asked you to do. Now you don't put this into your equation, you put the whole thing into your equation. So if you do that again, you should get x2 equaling 1.4373. And that's it. So that's your answer to this one. By choosing a suitable value, show that alpha is that to 3 decimal places. So what we've got to do is we've got to first of all decide what we're going to substitute this into. So what is it that we're trying to find? We're trying to find where g of x equals this thing here. So we're trying to find where 4e to the 2x minus 25 equals 2x plus 43. Therefore, if we're trying to find the value of x that suits this, what we need to do is set it equal to 0. And they're saying that this is a solution to that. So if that is the case, what we need to do is we need to then do f of 1.4365 and f of 1.4375. Now, let me explain that. They're saying that 1.437 is correct to 3 decimal places, which means that 1.436 will be too low, and 1.438 will be too high, which means that halfway between that 1.4365 and 1.4375, that must be the upper and the lower limit, so therefore it should be lying between there and there. So therefore, if one of them is positive, one of them is negative, it means there's been a change of sign, so therefore the root lies in this interval here. That's what we do. So you're going to substitute 1.4365 into our equation, 1.4375 into our equation. So if we substitute 1.4365 into this thing here, that gives us minus 0.113. And if we do it with 1.4375, you end up getting 0.027. So therefore we see that 1.4365 is negative, 1.4375 is positive. So therefore we say that the change in sign indicates a root or slash solution between 1.4365 and 1.4375, therefore 1.437 to 3 decimal places, and that's enough to get you the mark for that one. So whenever it says by choosing a suitable interval show that this is correct 3 decimal places, what we do is we go 0.5 above and below that, or in this case 0.0005 above and below that, and then you show that there's a change of sign. So let's have a look at the 2015 version of this question. So we've got y equals 2 to the power of x plus 1 minus 3, and y equals 17 minus x. The curve and the line intersect at point A show that x coordinate of A satisfies the equation is here. So what happens is that we've got to set them equal to each other. So where two things intersect is where they equal each other. So we're going to say that 2 to the power of x plus 1 minus 3 equals 17 minus x. So if we've got to rearrange that to get x equals, and bear in mind we've got some logs going on here, chances are that we need to take exponentials. Therefore, what we're going to do is get this minus on the other side first of all. So 2 to the power of x plus 1 equals 20 minus x. Now in order to get these powers down, we're going to need to take logs of both sides. So if we take logs of this side, so 2 to the power of x plus 1 equals log of 20 minus x, then, and that's where this bit comes from. So if we bring this down, that's going to be x plus 1 log 2. So again, all we've done is bring the power down using that log law, which we learnt in C2, equals log of 20 minus x. Now if we divide both sides by log 2, we're going to have x plus 1 equals log of 20 minus x divided by log 2. And then we've got this plus 1 on the end, so x equals log of 20 minus x over log 2, and then minus 1. And that's that first bit there. So again, it's looking a little bit more at log laws. Then we've got to use this iterative formula. So again, all we do there with the iterative formula is we just substitute a value of 3 into this, but because we've got 3 marks for this, so we've got over 3 minutes to do it. So we're just going to take our time. So we've got 3.5 minutes to make sure that we do this properly. So we're going to substitute 3 into that, and I'm going to write down what we get. So x0 equals 3, x1 equals, x2 equals, and x3 equals. And remember, we don't round. We only write down the rounded answers, but we use the complete answer. So put that into the calculator. 3 decimal places, x1 I get 3.087. And then what you do is you put that answer back into the calculator, and you get 3.080. And then you put that answer back into the calculator, and you get 3.081. Give your answer to part B to deduce the coordinates of point A, giving your answer to one decimal place. So what we could do is we could do that another time just to check to see what it goes to. So I'm saying that we don't really need to because it's only to one decimal place. So therefore, your value of x is going to be 3.1. That's going to be the x coordinate where they intersect. And then what we've got to do is we've got to find the y coordinate. So we can either put it in this one here, or we can put it in this one here. We should end up getting the same answer. So y equals 13.9. Therefore 3.1, 13.9. So 2014 question on this. It says the curve crosses the x-axis at point Q and minimum turning point at R. Show that the x-axis of Q lies between 2.1 and 2.2. So what it's saying is that, to a lesser extent, 2.1 is going to be here and 2.2 is going to be here. So that means that if you put in 2.1, that's going to give you a negative value. If you put in 2.2, it's going to give you a positive value. So as long as there's a change of sign when you substitute in your value of x, it means that Q will be between 2.1 and 2.2. That's what we do. You say y equals 2 cos, and if we're doing cos of this, therefore we're going to need to be in radians. So 2 cos of the half of 2.1 squared plus 2.1 cubed minus 3 times 2.1 minus 2. That equals that. Then you do the same for 2 cos half of 2.2 squared plus 2.2 cubed minus 3 lots of 2.2 minus 2. And if you do that, the answers that we get are, I've got it right, minus 0.224, which looks good. If we do the same for 2.2, fingers crossed, yes, 0.546. So we say that the change of sign indicates a root between, in the interval, 2.1 to 2.2. So that the x-coordinate of R is the solution to this. Okay, so the x-coordinate of R. So R is this point here. Now R is what is the turning point. Now the thing that we know about turning point is when the gradient is 0. So what have we got to do? We've got to differentiate and set it equal to 0, and then get x equals. So dy by dx equals. So when you differentiate cos, it's going to go to minus sign. So it's going to be minus 2 sine half x squared. But because you haven't just got an x here, you then differentiate whatever this is and put it at the front. So if differentiate half x squared, it's going to go to a half times 2x, which is x. So we can take that x and put it at the front there. Plus 3x squared minus 3. And then we're going to rearrange to get x equals. And if you have a look here, we've got this square root, which means chances are we're looking at this value of x here. So we're going to set that equal to 0. So make sure we've got that there. Minus 2x sine of a half x squared plus 3x squared minus 3. If we want to make this x the subject, get this and this over to the other side. So we've got 3x squared equals 2x sine of, so I should put that in brackets, sine of a half x squared plus 3. And you divide through by 3 to get x squared equals 2/3 x sine of a half x squared plus 1. And then you square root it, so you got x equals square root, oh, in fact they put this one at the front, so 1 plus 2/3 x sine of a half x squared. That's it, that's what they've got there for 4 marks. Again, that's just recognizing that r is the turning point, so we differentiate it, set equal to 0, and then rearrange to get x equals. Doesn't matter if you didn't get that though, because the next part is the iteration part. So all we've got to do is we've got to substitute in our value of x. So x0 equals 1.3. So what we're going to do is put x is 1.3 into this, into that. And if you do so, I'm going to pause the video and put it into my calculator. And doing that gives us x1 is 1.2838. So that's going to go to 4. Again, you put in your whole answer into that again. And if you do that, you get 1.276. And that's that. So congratulations if you've got through that, and that's how to do all the numerical method stuff.